So, speaking of astronomical units, here it is. Just again, it's the distance from the Earth to our sun, which is about 1.5 by 10 to the 11 meters. We actually use this unit of distance pretty commonly in terms of astrophysics. We don't tend to use the normal distances, such as meters and kilometers, because they can be absolutely ginormous. So, it either tends to be in terms of astronomical units or this other unit known as a parsec. Now, what the hell is a parsec, you might wonder? Well, this is it. A parsec is about 3.09 by 10 to the 16 meters, and how it's derived is actually due to something known as, or how we'll get to, is redshift. But we can also do it by way of this thing known as parallax. So as we're moving, stars can appear to shift as we are rotating about the Earth, or about our axis. Now, let's first check my ultimate device. Yeah, there's a thing for small angles and stuff. But how we do it? So if we imagine our Earth, yeah, color can be running here. So if you imagine our Earth, and we want to find a star. So let's say there's a star over here. We want to find the distance to. Call that distance d. We actually measure that by waiting until we've completed of um, some cycle of our orbit. So this will be a planar angle alpha. Then the star that's actually following us, or appears to be following us, has actually also moved a corresponding distance we'll call L. Now the angle between D and L is the angle in question, theta. So if we make sort of this triangle, the angle formed by here, this angle theta, uh, we can find out and use that to find the distance, the rough distance between the Earth and the subsequent star. Now, we've defined one parsec. We've defined a parsec as sort of the distance that the star moves if the angle subtended is 1 arcsecond. Now, an arcsecond is 1/60th of a 60th of a degree. So what that means is 1 degree you can split up into 60 what are known as arc minutes, which can further be split up into 60 by 60 or 3,600 arc seconds. You might have seen this before if you've looked at how the imperial units are derived. I think a nautical mile is sort of the relative distance on 1 arcsecond around the Earth. It's something like that. But how we get a parsec is having this subtended angle theta be 1 arcsecond. The next video I will show why we can do this, because normally you'd have a sine theta in here, or even actually a tan theta would work as well. But I'll just show in the next video because it's slightly more mathematical than physicsy. But it can show that sine of a pretty small angle is approximately the same as that angle in radians. So if you're interested in the maths behind it, you can look at the next video. Otherwise, you can skip it if you want.